This is the new content on conformal mapping, that is some special bilinear transformations. And let's recall these two theorems which are very important. First, every Mobius or bilinear transformation maps circles or straight lines into circles or straight lines. And every bilinear transformation transforms 2 points, which are inverse points with respect to the circle, into 2 points which are inverse point with respect to the transformed circle. Right? Okay. So in this connection, it is very important to know that straight lines are regarded as a special class of, yes, circles. And the inverse point of a given point with respect to a straight line is simply reflection of that point in the straight line, right? If you look at over here in the W plane, let's say this is the region mod W equal to C, the circle, and the inverse points with respect to this circle are 0 and infinity, right? So consequently, their image points are the inverse points with respect to straight lines or circle, whatever may be the case, right? We wish to find a bilinear transformation which transforms the real axis, that is y equal to 0, onto the unit circle mod W equal to 1, right? Let's say here C is equal to 1. So this is your unit circle. So this real axis y equal to 0 is transformed into the unit circle mod W equal to 1. So let's say the original transformation is AZ plus B over CZ plus D, where with the condition which is very important that AD minus BC should be non-zero. And suppose in the Z plane I'm having the real axis y equal to 0, and I have to transform this into the unit circle mod W equal to 1 in the W plane, right? And the inverse points with respect to mod W equal to 1, the circle in the W plane, the inverse points are 0 and infinity, right? With respect to mod W equal to 1. And then corresponding inverse points in the Z plane will be, yes. So from 1, when we get W equal to 0, if Z equal to negative B over A, then we get W equal to 0. So for W equal to 0, we get the inverse point in the Z plane as Z equal to negative B over A, right? And when the point W will be infinity, if Z equal to negative D over C, right? So for Z equal to negative D over C, we get W equal to infinity. Now as 0 and infinity are the inverse points with respect to mod W equal to 1, the circle, the unit circle in the W plane, we get the corresponding inverse points which are inverse points in the Z plane with respect to the real axis y equal to 0, right? So I can write, if this has to be as alpha, then because minus D over C is the inverse point of minus B over A, so I can denote this point as to be alpha bar, that is the conjugate of alpha, right? Okay. So this is just an introduction for the theorems which we are going to do in the next content, which are very, very important ones, and the proofs of those theorems are based on this concept, right? Okay, let's meet in the next video. Thank you.